Welcome to Miss Taylor's class videos for Algebra 1. Today we're going to talk about application of reasonable domain and range. And all we mean by this word application is we mean word problems. So what I want you to do real quick is I want you to fill in this table about our independent variables. Look at your 2.2, 2.3, and 2.4 notes for what our independent and our dependent variables are. If you don't have those notes, then go ahead and look at the completed class notes for them. So again, I always put these steps in here to help you guys out. The biggest one I'm going to talk about here is continuous versus discrete. So we're going to kind of make our little chart right here. So continuous, oh, that's spelled wrong, or the U is just really bad. So continuous means we have a line. It also means that we're going to use interval notation. So we're going to have a number less than x less than a number. Oh, that's a bad fancy bracket. That's an even worse fancy bracket. Sorry, guys. Discrete is going to be, it's going to be a list. It's going to be a table. It's going to be dots. And we're going to just simply list out our numbers. So 1, 2, 3, 4, 5. And so those are kind of the differences. If we're looking at graphs, it's really easy to tell continuous versus discrete. But in word problems, what we have to ask ourselves is, can we have half of our x? So for continuous, if we can have half an hour, then we know our data is going to be continuous. However, for discrete, we cannot have half a shirt. And so since we can't have half of a shirt, shirts would be discrete data. Since we can't have half a ticket, tickets would be discrete data. So if we can have a half, it's continuous. If we cannot have a half, it's discrete. All right, so a student is taking a test, and there are 10 problems on the test. For each problem the student answers correctly, the student is going to receive 10 points. So the first thing I like to do is I like to write an equation because it makes things simple. So f of x is going to be my y or be my total, and I know that each problem, it's going to be 10 points. So it's going to be 10 times x. So we got to figure out what our x is first. So our x is going to be correct questions. Because however many we get correct, we're going to multiply it by 10, which means our f of x, or our total, is going to be the grade that we get on the test. So let's think about how many questions that we could get right on a test. If it's a multiple choice test where there's no partial credit, which is what we're going to assume this is, you cannot get half of a question right. So you can get as few as 0 questions right on the test. You can get 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So again, you can't get 1.5, you can't get 3.5 because it's going to be a multiple choice test. So to find our range, we need to take our function and plug in our numbers for x. So we plugged in 0 for our x on f of x, which means we replace the x with a 0. So 10 times 0 is going to be 0. We're going to do the same thing for 1. 10 times 1 is going to be 10. And by then we've got the pattern: 20, 30, 40, 50, 60, 70, 80, 90, and then finally 100 is the best grade that we can get. So now let's look at some more examples. So Joe has a summer job that pays $7 an hour, and he worked between 15 and 35 hours every week. So Joe has a job that pays him $7 an hour. Remember, our per, each, every is going to be our x variable. So f of x equals 7x. There's no start, beginning, or initial, so that's all we need. So our x is always going to be whatever goes next to the number. So the x stands for hours. And then our f of x, or our y, is if he has a summer job, he's going to get paid. So it's going to be the total paid. So the problem gives us some very, very helpful information. It tells us the maximum and minimum numbers of hours that Joe's going to work. So we know that Joe can work half an hour, so this is going to be continuous. And because it's going to be continuous, we're going to use our interval notation. So the fewest hours Joe is going to work is 15. The most hours Joe is going to work is 35. And because he can work 15, we're going to use less than or equal to. So to figure out our range, what we need to do is we need to take our two numbers and we need to plug them into our function. So we need to do the function where f of x is 15. So that means we're going to plug 15 in for x. And we need to do f of 35, which means we're going to plug 35 in for x. So let me grab my handy dandy calculator real quick. So we've got 7 times 15, which is going to be 105, less than or equal to y, less than or equal to, and then we're going to go 7 times 35. Ooh, nope, 7 times 35. And we're going to get 245. So Joe is going to make somewhere between $105 and $245 each week because he's going to work between 15 and 35 hours. All right, so a company is selling shirts. The daily profit where the company makes depends on how many shirts they sell. The profit in dollars when the company sells X shirts can be found with the function. Oh, they gave us an equation. They're so nice. So we need to figure out what our X equals in the equation. So the company sells, oh, they were extra nice. So X is going to be shirts sold. Okay. And so now we have to find our F of X. So the profit in dollars. So profit is going to be our F of X, or our total money made. So we have to ask ourselves, can they sell half of a shirt? And the answer is no. No one's going to buy a shirt cut in half. So this is going to be discrete. And if it's going to be discrete, that means we're going to list out the values. So this one did not give us they make between this many and that many shirts. So our domain is going to be, they can sell 0 shirts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And I'm going to put a ... because they could sell over 1,000 shirts depending on what kind of company it is. So for our range, again, we've got to put it in function notation. So we need f of 0 equals 7 times 0 minus 80. So we're going to do 7 parentheses 0 minus 80. And so we get negative 80. So the first, if they sell 0 t-shirts, they're going to lose $80. So now I'm going to go and arrow up to the same equation. I'm going to delete the 0 and add a 1. So we get negative 73. Then I'm going to go up, do the same thing, plug in a 2. And we get negative 66. And then what I've noticed real quick is we're just adding 7. Delete plus 7 every time. Minus 59 plus 7 minus 52 plus 7 minus 45 plus 7 minus 38 minus 31, and so on and so forth. It's going to take them 12 shirts sold before they make money. Because if you went and you did that 7 times, you plugged in 7 for 12, that's the biggest, that's when you'll get above that $80. All right, so now I want you to try to do these next 2 on your own, and I want you to check your notes with the completed class notes.